Okay, now we're talking about electric charge. So our object is going to be to calculate the electric charge on an object and learn a little bit about where quantum mechanics came from. Now, we know that matter is made up of atoms. You've known that for a long time, and it can be broken down into smaller parts. Well, for electricity, obviously the most important parts are electrons. They're on the outside. They're the only part that can move from atom to atom, and they're kind of important in electricity. Electrons, electricity. Shocking. Now, most atoms, matter of fact, all atoms start out electrically neutral. That means they have a net charge of 0, the same number of positives and negatives. If they lose or gain electrons, they become ions. Now, if you lose an electron, you're going to have extra positives, so you're going to become positive. If you gain an electron, you're going to become negative. Now, charge comes in distinct quanta, and more about that later. It's quantized. It comes in distinct amounts. The charge on a single proton or electron is called the elementary unit of charge and is known as the elementary unit of charge, and we use E for it. And 1 E, the charge on an electron, is equal to 1.6 times 10 to the negative 19th coulombs. It's also the charge on a proton. Except for a proton, it would be a positive charge. For an electron, it would be a negative charge, but numerically they are the same. Now, 1 coulomb is 6.25 times 10 to the 18th elementary charges. It's essentially the reciprocal of 1.6 times 10 to the negative 19th. And the symbol we're going to use in equations for electric charge is Q. Now, let's look at a sample problem. An atom possesses an excess of 8 times 10 to the 6th electrons. It's got 8 million extra electrons. What is the net charge on the object? Well, we know 8 times 10 to the 6th electrons, and we know a relationship between electrons and coulombs. Remember, charge is going to be in coulombs. So if we multiply those together, the electrons are going to cancel out, leaving you with just coulombs, and if units are right, we're right. So we get negative 1.8 times 10 to the negative 12th coulombs. That's not a very big charge, but 8 million electrons, really in the grand scheme of things, is not that big. Now, an alpha particle has 2 protons and 2 electrons. Now, the important thing to understand is 2 protons and 2 neutrons. It's the 2 protons. So what I have is 2e, and then I want to go e's on the bottom to get rid of them. I want coulombs on the top, and of course I know that 1.6 times 10 to the negative 19th coulombs is equal to that. Your e's cancel out. So you're going to get 3.2 times 10 to the negative 19th coulombs. Now it's positive since they're protons, so that's the charge. Now, which quantity of excess charge can be found on an object? Well, we know that they have to occur in distinct amounts. I can't have part of an electron, so therefore that one won't work. I can't have 1.6 electrons. Can't have 6.25 electrons, so that won't work. It has to be a multiple of 1.6 times 10 to the negative 19th, so that one doesn't work. The winner, 4.8 times 10 to the negative 19th. That would essentially be 3 extra charges. What is the net electrical charge on a calcium atom when the calcium atom becomes an ion by losing 2 electrons? And that's the important thing. So if you're losing 2 electrons, you're going to become positive. Again, you're going to have 2 extra positives. So therefore 2 extra positives corresponds to that number. Hope this helps. Stay tuned for more.